The Tectonic Assemblies Studio is a collaborative effort between two disciplines, Master of Architectural Tectonics and Master of Computational Design and Fabrication. The studio is structured around system thinking in architecture through the lens of assembly and disassembly. It challenges students to engage critically with material behavior, fabrication techniques, and computational workflows, all towards developing adaptable, sustainable design systems. Students began with a hands-on study of timber, concrete, metal, and clay, tasked to fabricate three geometries, a cube, a cylinder, and an octant, using joinery or fabrication methods that would allow complete assembly and disassembly. This process was not only about understanding material constraints and potentials, but also about setting up a mindset for modular reversible design. With that as foundation, students were then asked to design a pavilion situated along the Sabarmati Riverfront. The brief was anchored in three core ideas. The proposal must engage with at least one of the UN Sustainable Development Goals. It must foreground the principles of assembly and disassembly at both material and structural levels. It must accommodate functional programs such as exhibition, gathering of approximately 75 people, and related public activities. Through iterative development and collective discussions, four major themes have emerged. First, zero waste construction strategies. Designing with precision to eliminate waste and enable sustainable reversible construction systems. Second, modularity and adaptability. Flexible modules support scalable assemblies and spatial versatility across diverse site conditions. Third, passive cooling through evaporative principles. Architectural forms channel air and moisture to enhance climate responsive comfort. Fourth, reuse and upcycling of scrap material. Discarded elements are reimagined through adaptive detailing and circular design thinking. Each theme is explored by a group of 4 to 5 students who have responded to the brief through diverse conceptual, material informed, and computationally structured tectonic frameworks. Throughout the semester, students shifted between computational modeling, digital fabrication techniques like CNC milling, laser cutting, 3D printing, and traditional craft methods like press casting. Tectonic Assemblies offered students an opportunity to bridge digital and physical realms, to think systematically and prototype future architecture rooted in material performance and sustainability. Thank you.